Welcome to Hangar 51 Files, where history's secrets, classified operations, and hidden truths come to light. From Cold War black ops to the future of warfare, from lost artifacts to emerging defense technologies, we investigate the stories buried beneath official narratives. No speculation, no clickbait, just hard-hitting research, expert analysis, and the pursuit of truth. You're now inside the briefing room. Stay sharp, stay curious. This is Hangar 51 Files.
Welcome to the Deep Dive. Today, we're plunging into the mysteries of our closest planetary neighbor, Venus.
That's right.
We've got a fascinating stack of sources to explore, from NASA's big report on the Pioneer Venus mission, some really intriguing Soviet Venera findings.
Including that controversial paper about possible plant-like forms.
Exactly. And also a critical look at some of those findings, plus a peek at future exploration plans.
Yeah, our goal today is really to pull together what these incredible missions showed us about Venus. You know, it is superheated atmosphere, that hidden surface, and, well, that lingering question about life.
Right. We're aiming for those aha moments, looking at the surprises, the twists, and also being honest about the big questions we still can't answer.
Definitely. Venus keeps a lot of secrets.
Okay, so let's kick things off by looking at the Pioneer Venus mission. December 1978, Venus suddenly became a real hotspot for spacecraft, didn't it?
Oh, absolutely mind-boggling. You had 10 spacecraft arriving the U.S. Pioneer Venus orbiter and its probes, plus the Soviet Venera, 11 and 12 landers and flybys. Quite a crowd.
What a moment for planetary science.
It really was. And what's interesting is, while the U.S. and Soviet missions weren't, actively coordinated day to day, each side knew what the other was generally planning. And later, crucially, they exchanged their scientific results through a joint working group.
That collaboration must have really amplified the findings.
Immensely. It speaks to that shared scientific curiosity,
Yeah. And the Pioneer Venus mission itself, that was a real feat of engineering, wasn't it? An orbiter and a multi-probe system?
A very clever design. The orbiter was meant to stay long-term, studying the atmosphere from above, mapping the surface.
Peering through those clouds with radar.
Exactly. Well, the multi-probe was the atmospheric assault team. It had the main bus, a large probe, and 3 smaller probes, all designed to plunge in.
So getting data from different altitudes and locations simultaneously?
That was the idea. Sampling from the edge of space right down to the surface or near it. A true atmospheric dive.
And this wasn't happening in a vacuum, right? It built on earlier missions.
Oh, yes. It stood on the shoulders of NASA's Mariner flybys and the early Soviet Venera landing attempts. Each mission peeled back another layer of the mystery.
Now, launching something this complex takes time. The orbiter and multiprobe launched separately in '78. But I read about this precursor mission, PAE, Planetary Atmosphere Experiments Test.
Ah, yes, PAE in 1971. That was essentially a high-stakes dress rehearsal.
How so?
They basically launched a probe and then slammed it back into Earth's atmosphere at 15,000 miles per hour.
Wow, why?
To brutally test the heat shields and the instrument designs they needed for entering atmospheres like Venus's or Mars's, a vital, if fiery, validation step.
A trial by fire, literally. And the original Pioneer Venus plans were even more ambitious, weren't they? Something about 2 identical spacecraft.
That was the initial concept back in the mid-'70s, yeah. 2 spacecraft, each with a bus that would skim the atmosphere, a large probe with a parachute, and 3 smaller probes.
So even more probes than they ended up sending.
Exactly. But, reality intervened. Congressional funding, authorization delays. It pushed the timeline back and led it to the revised 1978 plan with a separate orbiter and multiprobe.
Classic space mission story, big dreams meet budget realities.
Pretty much. It's often a balancing act.
And the science team behind this was huge, right? Over 100 scientists.
114 scientists involved, yeah. With a core science steering group coordinating all the different instrument teams and disciplines.
And getting your instrument onto the spacecraft wasn't guaranteed, was it? I heard there was competition, like with the mass spectrometers.
That's right. NASA actually funded 2 different teams to develop neutral mass spectrometers in parallel. One at Goddard, one at the University of Texas at Dallas.
And then they picked one.
Yep. An instrument review committee assessed both. And NASA HQ made the final call, selecting the University of Texas instrument. Rigorous process.
Speaking of challenges, that neutral mass spectrometer had a tough job dealing with Venus's atmosphere, going from near vacuum way up high down to crushing pressure. How'd they manage that?
That was a brilliant piece of engineering. The instrument itself needs a very specific low pressure to work.
Right.
So the inlet system had to reduce the outside pressure by a factor of, get this, 10 billion.
10 billion. How?
Using a tiny ceramic leak and the special valve that adjusted automatically, it let just enough gas trickle in for analysis across that enormous pressure range. A real tightrope walk.
Incredible. You hope those designs work. Now, the orbiter spacecraft itself, it spun for stability, but kept its antenna pointed at Earth.
Yeah, spin stabilized. The main body spun like a top, but the high-gain antenna was on a mast and could rotate in the opposite direction to spun to stay locked onto Earth for sending data.
Clever. And it had solar panels, hydrazine fuel for adjustments.
Standard stuff for deep space missions, solar power, hydrazine thrusters for orientation and course corrections, and crucially redundant backup systems.
Always need backups. And communication, S-band and X-band, what's the difference?
S-band was the main channel for sending back science data. The X-band signal wasn't really modulated with data, it was used for a specific experiment.
Oh.
By sending signals at two slightly different X-band frequencies and seeing how they were affected, passing through Venus's atmosphere, the radio occultation experiment, they could learn a lot about the atmosphere's structure and density.
Ah, okay. And they also had basic antennas.
Omni antennas, yeah, for receiving commands and low-rate data, just in case. And of course, Doppler tracking.
Right, measuring the frequency shift to track its speed.
Exactly. Super precise velocity measurements down to fractions of a meter per second, critical for navigation and orbital analysis.
Now the multi-probe, similar systems, but built for a one-way trip.
Pretty much. Similar orientation control, similar propulsion, but one less thruster. Didn't need that big orbit insertion burn. Key difference. No onboard memory.
No memory, so it had to transmit live.
Live, direct-to-Earth broadcast during atmospheric entry. Each probe was yelling its data home as it plunged.
Talk about pressure. And getting them there needed a powerful rocket, right? Not the original Thor Delta.
No. The mission grew too heavy for the Thor Delta. They ended up needing the Atlas Centaur rocket for both launches to handle the weight and size.
And before launch, all the fiddly bits, pyrotechnics, loading fuel.
Meticulous work. Installing the ordnance for separations and deployments, carefully loading the toxic hydrazine propellant.
Yeah.
Everything double-checked.
Then the launches orbiter in May 78, multi-probe in August. Must have been tense.
Definitely. And the multi-probe then needed a significant course correction maneuver mid-flight to hit its target precisely. Almost a full day of engine firings.
And things sometimes go slightly wrong, right? Didn't the multi-probe have a receiver issue?
It did. They detected a potential problem with the primary receiver and proactively switched to the backup.
And the backup worked fine.
Flawlessly for the rest of the mission. Good thing they had it. The primary was never used again.
Navigation using that Doppler data sounds incredibly precise.
It is. By measuring those tiny frequency shifts, they constantly refine the trajectory. Accuracy is key when you're aiming for a specific entry point millions of miles away.
There was that weird blip just before probe separation, though. Unexpected Doppler readings.
Yes, that caused some concern. After a maneuver to orient the multiprobe, the Doppler data looked a bit off.
What did they think it was?
They even considered a tiny, unintended thrust, maybe from a minuscule propellant leak. I had to understand that before committing to releasing the probes.
So much calculation involved in picking where the probes and the bus would enter, too?
Oh yeah, a complex puzzle. They wanted to sample different latitudes, longitudes, day side, night side, but also needed to make sure Earth could receive the signals during descent. Lots of constraints.
Then the big moment for the orbiter, orbit insertion, firing the engine behind Venus.
December 4th, 1978. Firing behind Venus meant they were out of contact during the crucial burn.
Nerve-wracking.
Totally. They had to trust the calculations. That 30-second burn slowed it just enough for Venus's gravity to capture it into that initial, highly elliptical orbit. Timing had to be perfect.
And once it was safely in orbit, the instruments came alive. Infrared, mass spectrometer.
Yep. Deploy the radar antenna, deploy the magnetometer boom, then switch on instruments like the infrared radiometer for temperature, the neutral mass spectrometer to sniff the upper atmosphere, the electron temperature probe, starting the science.
And the orbit itself changed over time.
They adjusted it periodically, and because of how Venus and the spacecraft moved, the point of closest approach periapsis gradually shifted relative to the Sun over Venus's long year.
Then came December 9th, probe entry day. All 4 probes and the bus taking the plunge. How did the big probe descend?
The large probe had a heat shield, then deployed a parachute high up. But around 47 kilometers, it jettisoned the chute and just free fell the rest of the way. Took about 55 minutes total.
And the 3 small probes?
They were simpler. Just used their heat shields or deceleration modules to slow down, deploying instruments as they fell. No parachutes.
And transmitting data all the way down despite the thickening atmosphere.
Yeah, the signal got weaker as they went deeper, so the data rate had to be reduced. But the Deep Space Network antennas on Earth managed to stay locked on.
And incredibly, one small probe survived landing.
Yeah. The day probe hit the surface and kept transmitting for another 67 minutes, way beyond expectations.
Amazing resilience. And those first results started coming out pretty quickly, causing a stir.
Oh, yes. Some really startling, unexpected findings were announced shortly after the encounters. It really shook up our picture of Venus.
Okay, so now we've set the stage. Let's dive into those scientific findings, really peel back the layers. The orbiter was just packed with instruments, wasn't it?
An absolute flying laboratory. Magnetometer, plasma analyzer, electric field detector, UV spectrometer for atmospheric glows and clouds.
Mass spectrometers for composition.
Neutral and ion mass specs, yes. Retarding potential analyzer, electron temperature probe for charged particles, infrared radiometer for heat.
Cloud photopolarimeter, radar altimeter.
Exactly. Plus atmospheric drag measurements, radio occultation, even a gamma-ray burst detector, a really comprehensive payload.
And the large probe wasn't lightweight either.
No, it carried its own suite. Atmospheric structure experiment, temperature, pressure, nephelometer for cloud particles, net flux radiometer for energy balance, another neutral mass spectrometer, and a gas chromatograph for detailed gas analysis.
And the small probes, still useful.
Absolutely. Each had an atmospheric structure package, a nephelometer, and a net flux radiometer, crucial data points from different locations.
That gamma-ray detector on the orbiter, that ended up doing astrophysics too, right?
Yeah, a fantastic bonus. It detected 6 significant gamma-ray bursts, including some really intense ones. One was later linked to a supernova remnant in the Large Magellanic Cloud.
Planetary missions contributing to cosmology.
Yeah.
And the orbiter lasted way longer than planned.
It did. They managed the propellant so well, it had enough left for at least another 486 Earth days of operations after its primary mission ended. Huge bonus for science.
Now, before Pioneer, Venus was just this bright, fuzzy disk, right? We didn't know much for sure.
Very blurry picture. Featureless through telescopes. Rotation period uncertain. Surface temperature and pressure were educated guesses at best, even into the late 50s. We knew the atmosphere was thick, but not how thick or what it was made of exactly.
So Pioneer's radar mapping was revolutionary. Over 90% of the surface mapped. What did it show?
It unveiled this hidden landscape. Huge continent-sized highlands like Ishtar Terra, home to Maxwell Montes, the highest mountains on Venus and Aphrodite Terra. Comparable in scale to Earth's continents.
Ishtar Terra is like Australia-sized?
Roughly, yeah. And its high plateau, Lakshmi Planum, is like a supersized Tibetan plateau. We also saw features that look like rift valleys, like Diana Chasma.
And the radar gave more than just height, right? Roughness, conductivity.
Yes, the altimeter gave height data accurate to about 150 meters, plus estimates of surface electrical conductivity and meter-scale roughness clues about the rock types and geology.
Okay, atmosphere surprises. The upper atmosphere was cooler than Earth's. That seems counterintuitive, like being closer to the sun.
It was surprising. Despite getting twice the solar radiation, Venus's upper atmosphere was cooler. And the night side had this incredibly cold layer, the cryosphere, unlike Earth's hot thermosphere. A really sharp temperature drop from day to night up there.
So Earth-based models didn't work?
Not really. Venus showed us our assumptions about how upper atmospheres behave weren't universal.
And deeper down, the atmosphere wasn't as turbulent as expected.
Below the main cloud decks, much of the atmosphere seemed quite stable, stratified, more like Earth's stratosphere than its churning troposphere. Less deep convection than theories predicted, despite the surface heat.
Fascinating. Now, the clouds themselves. Pioneer confirmed sulfuric acid, right?
Strong evidence, yeah. Concentrated sulfuric acid droplets, especially in the upper cloud layers, and highly corrosive stuff.
And not just one uniform layer.
No, a complex structure.
Yeah.
Multiple distinct layers with different particle sizes and refractive properties in each. The Venera lander's data back this up too.
And those UV markings, the zones, the haze, the polar collars, what do they tell us?
Those UV images showed a really dynamic system. You see large-scale zones, a pervasive haze layer, bright polar regions, all embedded in incredibly fast winds blowing mostly east-west.
The superrotation.
Exactly. And there's significant vertical wind shear winds changing speed rapidly with altitude. We saw these features change over time too.
But even with all that, clouds still hold mysteries.
Oh, definitely. What exactly is the unknown UV absorber creating those dark patterns? What are the larger Mode 3 particles really made of? What's the role of chlorine? Is there lightning? How does precipitation work, if at all? What about the haze below the main clouds? Lots still to figure out.
Okay, atmospheric composition. Pioneer and Venera agreed mostly. CO2 dominant.
Yep, the consensus is about 96% carbon dioxide, maybe 4% nitrogen. Surface pressure around 94.5 times Earth's. Temperature a blistering 732 Kelvin, or 460 Celsius.
Lead melting temperatures.
Right. Interestingly, the total amount of CO2 and nitrogen outgassed seems similar to Earth's, but Venus has less argon than expected.
But the argon isotopes were similar to Earth's. What's the significance of that?
The ratio of argon-38 to argon-36 being almost identical suggests Earth and Venus grabbed their initial noble gases from the same part of the primordial solar nebula, a clue about their shared origins.
But water vapor remains a puzzle. Different instruments gave different readings.
A real headache. Pioneer's mass spectrometer saw very little water high up. Venera's optical sensor suggested a bit more, decreasing lower down. Pioneer's gas chromatograph gave yet another value. Measuring tiny amounts of water accurately in that hellish environment is just incredibly hard.
Another key difference. Venus lacks a strong global magnetic field like Earth's.
Seems so. No significant internally generated magnetic field. This suggests its core might be different, maybe not convecting molten iron the way Earth's does.
And that affects how it interacts with the solar wind.
Massively.
Well,
Without that protective magnetic bubble, the solar wind slams much closer into the upper atmosphere, creating a bow shock near the planet.
but the ionosphere density is similar to Earth's.
Surprisingly, yes. The density of charged particles in the upper atmosphere is comparable, and Pioneer clearly saw the sharp upper boundary, the ionopause.
There's that interesting idea that Venus kept more of its original atmosphere from the solar nebula.
That's one hypothesis, yeah.
Yeah.
That unlike Earth and Mars, which lost early light gases and rebuilt atmospheres through volcanism, maybe Venus held on to more of its initial hydrogen-helium-rich envelope, a very different evolutionary path, if true.
And the Venera landers directly sniffed the air at the surface.
Their Sigma gas chromatograph gave detailed composition data right down low. Venera 11 and 12 also measured the sky brightness and spectrum deep in the atmosphere, which surprisingly helped estimate water vapor, too.
But Venera 11's cloud instrument suggested lots of chlorine, more than sulfur.
That was a bit of a curveball, yes. The prevailing idea was sulfur compounds, mainly sulfuric acid. The Venera nephelometer data hinted chlorine might be a major player, maybe even dominant, challenged the consensus.
So the main Venera goals were chemical analysis, cloud studies, thermal balance.
Exactly. Understand the gases, the clouds, the energy budget.
And having both U.S. and Soviet missions using similar instrument types must have been valuable for cross-checking.
Hugely valuable. Independent measurements confirming each other builds confidence. Mass specs, gas chromatographs, nephelometers, radiometers on both sides. It helps solidify the picture.
Back to the solar-wind interaction, all those missions together helped refine the picture.
Yeah, Venera, Mariner, Pioneer. Observations of the bow shock and the plasma environment confirmed Venus lacks a strong intrinsic field, but showed it has an induced magnetosphere and tail formed by the solar wind interacting directly with the ionosphere. Different mechanism than Earth's.
And the night-side ionosphere was weird. Double peaks in density.
Sometimes, yes. The radio occultation data showed these irregular profiles on the night side. Why? Still debated. Maybe plasma transport from the day side, maybe some unknown local ionization source. Still working on that.
It sounds like our models of the upper atmosphere generally matched the Pioneer data, though.
Broadly, yes. Models developed by various groups, including Soviet scientists like Marov and Rabov, were generally consistent with what Pioneer Venus measured directly in terms of density, temperature, and composition up high. Good convergence there.
And Pioneer Venus got that bonus observation of Halley's Comet.
Incredible luck. Being in orbit around Venus, just as Halley swung by in the 80s, they turned its instruments towards the comet and got unique data, a great example of mission serendipity.
Thinking back, early Venus observations were tough. People even thought they saw a moon.
Yeah, those 19th century claims turned out to be faint background stars. And estimating the rotation period was all over the map for decades. The surface was just totally hidden.
Until radio waves and radar changed everything.
Key breakthroughs. Detecting strong radio waves in the late 50s hinted at a super hot surface. First radar echoes in the early 60s proved we could probe beneath the clouds. And then seeing UV cloud features zip around in 4 days showed the atmosphere rotated much faster than the planet itself.
And once radar started revealing features, we needed names.
Exactly. Since you couldn't see anything, names came from radar data. Alpha and Beta Regio were the first. named informally by radar astronomers.
And then the official system came in, mostly female figures.
Yes, the International Astronomical Union established the convention, mostly named after goddesses and heroic women from myths and history across global cultures. Large features like Ishtar Terra, Babylonian goddess, and Aphrodite Terra, Greek goddess.
Maxwell Montez being a notable exception.
Right, named after James Clerk Maxwell, whose physics underlies radio waves. But mostly female names for mountains, plains, canyons, reflecting a global effort.
A hidden world with names drawn from human stories. Now, let's get into something more speculative. That Stems of Plants paper based on Venera 14 images. What was the claim there?
The author looked very closely at the Venera 14 panoramas and identified several objects they felt resembled stems or even flower-like shapes. One in particular, nicknamed Jaggy, seemed upright, cast a shadow, and looked lighter than the rocks.
So potential signs of life.
That was the interpretation offered. But, these are relatively low-resolution images of a completely alien, incredibly harsh environment. Proving something like that from images alone is, well, extremely difficult.
The paper mentioned terramorphism, the idea that life might evolve similar shapes elsewhere.
Yeah, the idea that similar environmental pressures might lead to similar forms even on vastly different worlds. It's a thought-provoking concept. The author acknowledges it's not proof, but argues it shouldn't be dismissed out of hand just because Venus seems so hostile.
Raising questions about scientific bias against finding life there.
That was part of the argument. Is our certainty that Venus is lifeless preventing us from seeing potential evidence? It's controversial, obviously.
You can see why it would be controversial. Extraordinary claims need extraordinary evidence.
Precisely. And blurry shapes in old images, while intriguing, don't meet that bar for most scientists. You need much more direct, unambiguous evidence.
Okay, let's shift to the paper on the Venera 9 and 10 surface findings. These gave us the first actual pictures from the surface of another planet, right? Monumental.
Absolutely groundbreaking. Venera 9 and 10 landed in different spots within that Beta Regio area. Their cameras about 90 centimeters off the ground, scanned side to side, giving us those first panoramic views.
And what did the direct measurements show? Conditions as bad as expected.
Pretty much confirmed the hellish conditions. Temperatures around 460, 470 C, pressures 88, 94 times Earth's. Consistent between the two sites, suggesting similar elevations. They also found low wind speeds near the ground and confirmed CO2 dominance with a trace of water vapor.
And the pictures themselves, Venera 9 landed on a slope.
Yeah, and his images show lots of sharp-edged layered rocks, sort of like slabs. Also a more rounded boulder that looked like smaller pits stuck together in a agglomerate.
Suggesting geological processes at work. Weathering.
That was the interpretation. Potential chemical weathering from the atmosphere, oxidation, sulfidation. Also signs of degradation, like rounded edges and pitting on the rocks.
But it wasn't quite like Earth geology.
No. Features like truncated layers plus the inferred high density of the rocks didn't quite fit Earth-based sedimentary models. It made scientists think maybe unique Venusian processes were needed to form and lithify rocks under that extreme heat and pressure.
Completely alien geology, potentially. Now, we also looked at that YouTube transcript. What the Soviet Union really found on Venus, life or mistake? That sounds like it pushes back on the life claims.
Likely, yes. That title suggests a critical perspective, probably arguing against interpreting those Venera image shapes as life.
Offering alternative explanations.
Probably exploring things like unusual rock formations, image artifacts, maybe even bits of the lander itself being misinterpreted. Standard scientific skepticism applied to an extraordinary claim.
Which is crucial, right? Having that debate and questioning is how science moves forward.
Absolutely essential. You propose ideas, others scrutinize them, look for flaws, suggest alternatives. That's the process. It prevents us from jumping to conclusions.
Okay, finally, that Venera.pdf, looking at future work. What are the big unanswered questions about Venus that still bug scientists?
There's several big ones. Why did Venus end up so different from Earth? What is that mystery UV absorber in the clouds? What's the detailed structure and dynamics of the clouds in that super fast wind system? What causes the faint night glow? Big fundamental questions remain.
And what kind of future missions are needed to tackle these? More landers? Orbiters?
All of the above, potentially. More advanced orbiters, longer-lasting landers, maybe even aerial platforms, balloons, or winged craft like VAMP to explore the atmosphere directly for extended periods.
And what would they measure?
Things like detailed elemental and isotopic composition of rocks and air, cloud particle microphysics, precise wind measurements at different altitudes, using advanced instruments like sophisticated spectrometers.
And didn't Venera 8 hint at unusual rock types?
Yes, its gamma-ray spectrometer suggested some rocks might not be basaltic, which is common on Earth and the Moon. That's another mystery future landers could investigate. What is the surface rock composition across Venus?
Wow. So despite everything we learned from Pioneer and Venera, Venus is still packed with mysteries.
Absolutely. Those missions were incredible, truly pioneering, but they opened up as many questions as they answered. There's so much more to discover.
Well, this deep dive has really hammered home what a world of extremes Venus is. A scorching furnace, crushing pressure, toxic clouds, yet strangely familiar in some ways and dynamically active.
The data from Pioneer and Venera gave us this incredible foundation, painting a picture of a world both similar to and vastly different from Earth.
And those lingering questions, those anomalies, those debated images, they really do make you wonder.
It leads to that provocative thought, doesn't it? Given the mysteries and those tantalizing hints, if life did somehow arise or adapt there, what truly radical, unexpected forms might it take in such a brutal place?
Are we just limited by our Earth-centric view of what life has to look like?
It's a question worth pondering. Maybe our definition of habitable or even life is too narrow.
A fascinating thought to end on. If you, our listener, want to explore more, definitely check out the NASA and Roscosmos archives on these missions. And keep an eye out for future missions, Veritas, Da Vinci, plus Envision. The next chapter of Venus exploration is coming.
It feels like we're on the cusp of potentially big discoveries there.
It really does. Thanks for joining us on the Deep Dive.
That's it for this episode of Hangar 51 Files, where we uncover the hidden, investigate the unexplained, and challenge the official story. If you found this episode insightful, make sure to subscribe, leave a review, and share it with those who refuse to accept surface-level narratives. For more deep dives, exclusive research, and behind-the-scenes content, visit www.hangar51files.com, our YouTube channel, at Hangar 51 Files, or our Substack, hangar51files.substack.com. Until next time, stay sharp, stay curious, and keep questioning everything. This is Hangar 51 Files, signing off. No speculation, no clickbait, just hard-hitting research, expert analysis, and the pursuit of truth.